So, any other question? I think this was yours. No? Okay, so it's here. Okay, let's get us started. Today we have another example of designing circuits, sequential circuits. Last class, we mentioned the systematic way. Last class, we had two examples. One Mealy design and one Moore design. The Mealy design, as you realize, makes the number of states a little less, but is sometimes more complicated. We want to do another example today, and that example makes some load pair conditions. Everyone go through that. It's a little more complex. We're going to see that. It's again sequence detector, but this time we want to detect two double one detectors. So the point is to detect double one. If the sequence coming and double one being there, like for example, this is the sequence, one after each other. So the input is W, this sequence coming. We want to detect input is Z, and we are actually edge triggered, and we want to use D flip flop in here, but we want to still use D flip flop because it's still we don't want to deal with complexity of other JK flip flop or T flip flop. So let's see how we can draw a state diagram. You have already there, but I want to draw it again to show you how we can draw that based off the definition. This is the definition of the problem. So we are detecting 1, 1 in a sequence. The first state that is coming to our mind is the state of S0. In this state, when the reset coming, we have a reset as well. We are in this state. And in this state, we call that no match. It means 0. If the 0 coming, we are staying in no match. Okay? If 1's coming, we go to another state, S1, and this is 1 match. 1 match. Okay. Because this is more design, is more, we need to specify output inside the state. Because output gets ready right away when a state gets ready. So the output here is 0 because we said the output is 1 when detect two ones, double ones, close to each other. Okay. We are in one match because 1 came. If there's 0 coming, we're going to come back to S0. Okay. So that's a nicer picture. Instead of a state 0, a state 1, and a state 2, we call A, B, C. Okay. Now I want to ask you, for example, in exam, we say, okay, this is a system. This is a state diagram for more design. And you do the Mealy design. I ask you, what is the state machine, a state diagram for Mealy machine? In these two match, we have output 1. 1, again, the output is 0 because it's just 1 match, not 2. If another one coming, we stay in that state, another print and create another output 1. If 0 coming, we're going to go back to state 0 and start again. So this is a state diagram for more design. If we want to make we're going to go to 2 match. Okay. Any question about that? I want to ask you for this example. Okay, let's show you the nicer picture. It's gonna be same. If 0 coming, we say in Mealy, don't have out inside the state. We have output in the transition. When we are make transition, we can make output. Okay, so that's one difference. I give you 2 minutes. Try to do it by yourself. I'm gonna come check. Okay. I'll do it. You can take a look at the last class because it's gonna be similar, not completely because it's different sequence, different inputs. So it's gonna be a little different, but the number of states gonna be the same. We have 2 bits to detect.
You guys doing? Is one of you, please?
Okay. Most of you guys that work on that, you did good. Mostly similar. You have 2 states. So it's the same. In this case, we have S0, state 0. There is still the state. Maybe I choose another color. State 0. We want to detect 1, 1. So if 0 coming, we stay in a state 0. And when 0 coming, we're going to stay in that state, and the output is still 0. 1 coming, we're going to go to 1 match. Still, the name of this state is no match. We're going to go to another state, S1, and is 1 match. And still, we didn't get 1, 1. We 0. In a state 1, if 1 coming, we stay in this state. And 1, 1 happened, so we're going to have the output 1, not 0. Okay. And if 0 coming, we go back to a state S0 and we print 0. Okay. So just gonna make same pattern as this based off any input, but with less states. We can design this with how many flip-flop? 1. Because 1 can make 2 states. And for that one, we're going to have 2 flip-flops and 1 don't care. That's why we want to do the Moore design to see the don't care case. Question about this? Any question about that? Good. Okay. So let's go for second step. Second step is to design a state table to show how the state changing based off input. We have input. Remember, even though it's Moore design, but we have input. We have input. So in Moore, the output, it depends on state, just a state, but a state depends on input. So maybe we show like that. In Mealy, output is a function of state and input. It means if input change, the state output change right away. But in Moore design that we are trying to do that, input just changes state, and it depends on clock. It's synchronized by clock. So clock is doing, synchronizing. It's controlling the circuit. clock controlling the circuit. But here is not under control of clock. Anytime input coming, whatever was before is going to change, and the output going to change. Okay, that's the important part. So this input, that's why I chose this example, because in this example, we have more design and also input. But input not changing output, sorry. It's changing a state, and a state change output. So we can say that input is a state is like a function that acting on input. Okay, so we want to design this one. So we need to mention how a state's changing. A state, based off this picture that we draw, easily you can say, okay, we have 3 states, A, B, C, or S0, S1, and S2, the picture that I draw, okay? And based off these inputs, if the input is 0, we're gonna stay in A, and if we are in B, again, we're gonna go to A, and even if we are in C, still we're gonna go to A. And if input 1, if you are in a state A, we're gonna go to B. If you are in B, we're gonna go to C. And if you are in C, and again 1 coming, we're gonna stay in the state C. Because doesn't matter if this is 2, 1 already there, another 1 coming, still you have 2, so you are still okay. And you print, and you make output 1. In this case, you make output 1. Okay, so that's it. The next step is to consider binary codes to that. For ABC, we need 2 binary digits, but we can make with 1, and 1 is not enough. We need to use 2. Because again, of log 3 by 2, this gives you 2. The number of flip-flop. Number of flip-flop digits. Yeah, so it's is 2. So we need 2 flip-flop and 2 digits. Any question about this part? Okay, now we know a state, and we know the coding for a state for 0, 0, 1, and 1, 0, and 1, 1 is extra state. So we just consider it, don't care. So we just change A, B, C with these numbers, and for the last state that is not gonna happening, we just consider don't care. So this table with the previous table is not that much changing. We just code them. Instead of A, B, C, we put 0, 0, 0, 1, and 1, 0. This is A, B, and C. Okay, and the output is the same. Now from here, we need to draw a kernel map to find a function, like simplified function, Boolean function, or expression. So let's do kernel map. One of these sequential problems is already have all of the things that you learned before. Like, for example, finding the code, the number of binary digit that you need to consider, or the kernel map, simplifying the Boolean expressions. They are all in one question. That's why I like to have multiple of these examples. So let's do for, okay, first of all, We want to see what is the Q plus and what is the Q. For example, this is D flip-flop. And D flip-flop, we have input and two outputs, Q and Q bar. And one input, we have clock or reset. We don't consider that. And for example, this is for Q1. We consider this input Q1 plus. So based off those Qs are present states, and Q plus is the newest state because a new input. And D flip-flop is like that. Anything you put as an input is going to be next state. That's why it's simple to design. That's why we start designing sequential circuits with D flip-flop first. So anything that you put input is going to be next state. I just wanted in that picture to show you which one is previous state and which one is newest state. When we put plus means it's newest state. But this newest state depends on W as another input. So we consider these inputs as well. Okay? Now let's design Carnot map. Carnot map is a little different. Okay, let's do first Q, because we want to compute inputs. Q1 plus. We want to design the Carnot map for Q1 plus. We have three variables, W, Q1, and Q2. These orders might be different. You can do it, you can choose like W1 here and W2 here. Doesn't matter. The result gonna be the same at the end. But it's better to consider them like it's better to, for example, because W is different, let's put it in like that. It's gonna help you to recognize what you are doing. It's not gonna be very complex. So 0 and 1, 0, 0, 1, 1, 1, 1, 0. Okay? Okay, let's fill it now. We are designing Q plus 1. Q plus 1. This is Q plus 1. Q plus 1, we have two. One for W1 and one for W0. First for W0, first row, 0, 0, 0, D. Don't care. The next one, 1, 0, 0, don't care. Did you get how I wrote that? Any question? Is it not complicated like before? Okay. Now we need to find the groups. Okay, you help me. We have 1, 1, and 2 don't cares. What is the best group? Any grouping? Can I group this one with anything else? There is no, nothing close to that. There is no neighbor. So and these we consider them 0, and we just get that as a one group by itself. So Q1 plus gonna be W, because it's for this, and here Q2, Q1, bar. Good? That's the first one. Let's go for Q2. Any question about that? Okay, another example of Carnot map. Let's clean this up. Have it in next slide too, so oh, let's go for Q2 plus. There is another one, another Carnot map that W Q1, Q2, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay. Let's go for Q2. This is Q2. Another Q2. One is for jump 0, 0, 0, 0, 1, 1, D. Okay, this one is a little trickier because we have two ones, one don't care in between. What is the best grouping? I choose this, another color. What about I group these three together? Can I? No. Why? Because it needs to be power of 2. It can be 3. But what about this don't care? Yes, that's the one. I can do this for sure. What I do with this one? Can I just make it one group by itself? Yeah, I can, but it's not optimal. What I can do it again with this don't care. Doesn't matter, overlapping a lot. Remember? So we do another one, these two. So it's gonna make the result of Q2 W1 plus Q2. I just summarize it at the end. It's gonna be 2, but you can factorize W out. Okay, so we have this. What about Z? For Z is so simple. It's just this one. And don't care too. That's actually a good one too. Let's route that. For Z, we have Q1 and Q2, 0, 1, 0, 1, 0, 1, D. So these two, and C gonna be Q2. Good. So we have these three. So this is another cleaner version. Now let's go design it. Okay. I already designed it. So anyway, in your slides, I think I wrote wrong. That's Q2. I wrote it Q1. Let's fix it. But this is the correct one. This is D2, and this is D1. This is correct one. I just wrote the numbers wrong in your slide. And this, how we find that? I just wanted to draw that, but this Q2 coming from Q1 plus Q2 W. That's the W input. And this one is Q1 plus is 2. Oh, maybe I start from W. W, Q2 bar, Q1 bar. That's it. What about Z? Z is Q2. That's how you design this diagram. What about inputs, other inputs, clocks? Let's clean this up. For clock, both are synchronized. They both connected to the same clock. And for reset, also the same. Because reset one is 0, 0, we connect them all together. If you in exam, I say reset is, for example, 1, 1, instead of connecting to reset, or maybe say, for example, you can use preset input to set it instead of reset. Got it? Okay. You can play with that. Yeah, I can say anything. I can say that the start is, for example, 0, 1. You can play with the reset and preset inputs because we have also preset. Okay, that's it. For this one, also we can design the like frequency way when input coming based off the clock. And for example, if the Q1 and Q0 are 0, first the clock coming, this becomes, the Q1 becomes 1. And is equal to Q2, Z is the same. And you can base off this input, you can find how these two changing. For example, here, still this is stay, and one coming again. So this is another one that coming, 2 ones. But after clock, we start changing that. So this after clock change. However, here this one is changing first, like this, and so forth. So we need to know how react based off the clock and inputs. If I give you example like that, so this is a good example for that. Any question? Okay, so that I clean this up. The answer for this is this one.